In this video, we are going to see how to analyze a non-recursive algorithm. So these are the plan or the steps that we have to follow for analyzing a non-recursive algorithm. So first we have to decide on the input parameter, that is we have to identify the input size. After identifying the input size, we have to define or find the basic operation that is present in the algorithm. We all know what is basic operation. The operation, the innermost operation if a loop is present, right? So the operation which is executed more number of times is known as basic operation. So as a second step, we are going to identify the basic operation of any given algorithm. After identifying the basic operation, we have to decide or check whether the number of times the selected or the chosen basic operation execution, whether it depends only on the input size or whether it depends upon some other parameter that is present in the algorithm. So we have to decide. If the basic operation execution depends only on the input size, then we need not go ahead with that. Simply we'll find the complexity. We'll not go with worst case, average case or the best case complexity. Suppose the number of times the basic operation gets executed does not depend not only on the input size, but if it depends on some other parameter, then we have to find the worst case, best case and the average case. Usually we'll not be talking or we'll not be finding all these three cases. We'll talk only about the worst case complexity, right? And after deciding upon these parameters, we'll set up an equation. As the last step, we'll solve the equation using the formulas, the standard formulas which we'll see now. These are the formulas which we are going to use to simplify the uh, formation. That is the formula which we have formed in step 4. Right? Just to go through it. So first example, we'll take this algorithm. That is given a list of values. We are going to find the maximum value that is present in the list. Just we'll go through the algorithm. See, it takes n elements as the input. So here they are assuming the starting index is 0. Hence the uppermost index value is n minus 1. So this is your input. And what is our output? The value of the largest element that is going to be present in A. Right? So initially they are taking the first value that is present in the list as the maximum value. Then they iterate. They starting from 1 to n minus 1, they iterate the process. So if the next value, that is if the ith value is greater than the maximum value, we update the max value. And the process continues until we scan all the elements that is present in the list or the end of the list is reached. So finally, we return the maximum value that is present in the list. So we are going to analyze this algorithm. This algorithm is an example for non-recursion because there is no recursive function present in this algorithm. So what is the first step? We have to identify the input size. So from the algorithm, it is obviously known that the size of the input is going to be n. So the input size is n. What is the second step? You have to identify the basic operation. So what is a basic operation? The operation that is executed more number of times in any given algorithm is known as the basic operation, right? So here when we observe, we have a looping statement. When a looping statement is present, then the innermost operation that is going to be present in the looping statement can be considered as the basic operation. But here, so what is the innermost operation? Max value is equal to A of I. But the execution of this statement depends upon the condition. If this condition evaluates to true, then this assignment operation takes place. If it evaluates to false, this assignment does not occur. Right? So, when comparing these two statements, this comparison operation or condition checking operation takes place more number of times. Hence, here we consider among these two statements, we consider this statement as the basic operation where it contains the greater than operation, that is the comparison operation. So in our example, that is the maximum value element identification algorithm, we consider comparison operation as the basic operation. Right. Next, what is the third step? We have to check whether the number of comparisons that we perform depends only on the input size. Yes. So here, starting from the first value, I have to iterate till the element that is present in the last index value, right? So because I'm going to, what is my target? I have to find the maximum value that is present in the list. So to find the maximum value, I have to iterate till the end of the list. So by sure, the number of comparisons that I do depends upon the number of values that is present in the list. Yes. So since it depends only on the input size, I need not find, or I need not go with worst case, best case, or the average case complexity. So simply I'll find it. What is our fourth step? Equation formation, right? So we write here a C of n. Why? Because is that C, comparison operation. C stands for here the comparison operation and the input size. Okay. Since it is not recursive, we write it as, that is, the limit ranges from 1 to n minus 1. So here 1 is this, that is the lower limit, and this is n minus 1, upper limit. So I just have copied this loop. So what is the value of I? It ranges from 1 to n minus 1. How many operations, how many basic operation do I perform for each iteration? I perform only one basic operation. So thus we get an equation like this, right? So in the equation, that is in the general equation that we saw, which we have listed out previously, from there you can infer that when I ranges from 1 to n, with 1, that is 1 plus 1 plus 1, that n number of times, it is nothing but n ones you'll get. So it is n there. But here what is the upper bound? N minus 1. So when you sum 1, that is, you'll get like this, 1 plus, because sigma here represents the sum. So 1 plus 1 plus 1 plus up to n minus 1 times you are to write like this. So how many ones you will get? N minus 1 you will get. So this we can write. So when we write it as a complexity, you can remove all the constants that is present as a multiplicative constant or additive or subtractive constants. And you can write, take only the variables for your complexity. So thus the complexity of this algorithm becomes theta of n. So exactly I am saying that it is theta of n. You can also write it as O of n. So it is of no issue. See, without analyzing, without going like this, following these steps, directly you can write the complexity. So for that, what you have to do, you have to identify the number of loops present in it. This is a shortcut, but when you are asked, but you have to follow the steps. Okay. So here, how many number of loops are present? Only one loop is here, right? So what is the maximum bound of this loop? N minus 1. So n minus 1, leaving that minus 1, the complexity becomes theta of n. We'll go ahead with one more example, the element uniqueness problem. It means that you are going to find whether the elements, all the elements that is present in a given list are unique. Unique na, there should, all the values should be distinct. If not, I'll say false, else I'll say true. Here input is the list of values. Let it be n number of values starting from the index value 0 to n minus 1. The output, it returns true if all the elements in A are distinct. Else it is going to return false. Right? So what is the logic which is used here? They are taking the first value present in the list and it is compared with all the remaining values of the list. If it matches with any of the remaining values that is present in the list, I'll say the list is not distinct because the elements present here contains duplicate values. Similarly, for every element that is present in the list, I'll compare that with the all the values, remaining values that follows it. Will be, that is the element, we'll take a particular value present in a position and we'll compare it with the other values present in the list, right? So if it matches, we say the element is the list is contain duplicate values, else we say that all the elements present in the list are distinct, that is unique. Okay. So now we'll analyze using the steps which we were using for the earlier example. So first is input size. Obviously, it is known it is of n size. Next, you have to identify the basic operation. Basic operation is the innermost operation. See here we have two for loops. So that in next the operation that is present within these two for loops. how to be considered as the basic operation. What is the equation or what is the programming line that is present? A of I is equal to A of j. See here it is not an assignment operation. So in our here in Anani Levitin, the assignment operation is done with the help of the zero mark. Here, since it is a pseudocode, it is not compulsory that the syntax of a programming language have to be followed, right? So this is a comparison operation. So this becomes our basic operation since this is the innermost operation. Next, you have to check for the dependency. So when we observe this algorithm, okay, innermost is comparison operation, but the number of times this comparison operation does it depends only on the number of values present in the list. According to this logic, it is not so. Why? Because is that we have a return statement here. So once it finds a duplicate element, it does not continue the comparison operation. Just immediately it returns false, right? So it is of no use. When I find a duplicate value in a list in the first position itself, then it is off. It is not necessary for me to continue the comparison operation. So I can discontinue and I can say that it is false, indicating that the element, the list in the elements, the elements in the list are duplicate, right? Contains duplicate values, right? So since the number of times this comparison operation takes place does not depends only on the input size, we have to go ahead with the worst, best and average case complexities. As told earlier, so here we are going to find only the worst case complexity, right? So what is the fourth step? We have to formulate the equation. The equation formation is very easy. So we, for every iteration, one comparison we are going to do. So one, what is the innermost boundary ij? What is the I plus 1 is the starting one, and what is the maximum value takes? It takes n minus 1. So that's what we have written here, right? So similarly, what about the outermost loop? So it contains a variable I. What is the starting value of I? It is 0. And what is the maximum limit of I? It is n minus 2. Right? So thus we have formulated an equation. Now we have to simplify. So note it down. Here we have indicated this as a burst. Why? Because here the number of times the basic operation execution depends not only on the inputs, it also depends upon some other parameter. Right? So now we have to simplify this equation. So how to simplify? So if I have that is 0 to n minus 1, if the equation is not so, here we are applying the formula u minus L plus 1. It is the one among the formula which we have listed out in the third slide. So u minus L plus 1. So this is going to be our lower bound and this is going to be our upper bound. So u minus L, what is L? I plus 1, then plus 1. So inserting this minus, you will get minus I minus 1 plus 1. So this plus 1 and minus 1 will get cancelled. You will get n minus 1 minus I. Now we have to apply this. See here we are going to apply the limit only on the variable I. So the remaining variables can be considered as a constant. So you are taking it out. Okay, you'll get it like this. So you are separating it. N minus 1 comes separately and I go separately. So this minus 1 is retained here. So now when we observe this again, here we apply limit only on the variable I. So I'll take this n minus 1 outside. So only 1 remains here. So 1. So this is again u minus, sorry, that is I 0 to sub 0. That is you have to sum the 1. How many number of times? N minus, sorry, okay, fine. So sigma is equal to 0, I n minus 2, right? So you can apply u minus L plus 1. So this is u here and this is your L. So u n minus 2 plus 0 we need not be. So plus 1. So you'll get n minus 1 again here. This becomes n minus 1 the whole square. Minus this again, this is 1, right? Sorry, this is I, right? So I now again you have to go ahead with. So here we can apply this n into, because I is present, this is I. So because I is present here, you can apply n into that n plus 1 by 2 formula. N into n plus 1 by 2 the formula. Here what is the value of n? It is n minus 2. So n minus 2 plus 1 it becomes n minus 1 by 2. So when you simplify this, you'll get n squared. You need not simplify till the end. Anyhow, the upper power is going to be n squared. The maximum value can be taken because we are going to find only the worst case. Thus, the complexity of this algorithm becomes theta of n squared. Even you can infer directly the complexity of this algorithm without computing all these things. Why? Because we have two for loops. So what is a bound of first for loop? It is n minus 2. Leaving the constants, you will get n. Similarly, what is the upper bound of the second for loop? It is again n. You are leaving the constants, you will get n, another n. So since nested n into n, so this becomes n squared. So directly you can infer and verify your answer. So thus we are able to analyze a non-recursive algorithm using the proposed steps.